In this video, we're going to see how we should solve the integral from 0 to 1 of arc sine x over x dx with respect to x. Now, in order to do this in this integral, let me create more space down here. We have to expand arc sine of x using the Taylor Maclurin series, and its Maclurin series is the sum from n equals 0 to infinity of 2n factorial divided by 2 to the 2n and n factorial squared times x to the 2n plus 1 over 2n plus 1. Now, if I divide arc sine x over x, in here my sum is going to be from 0 to infinity of 2n factorial 2 to the 2n and factorial all this stuff multiplied by x to the 2n plus 1 over x, which is going to be x to the 2n. So it's going to be x to the 2n over 2n plus 1. And now if I integrate it from 0 to 1, this integral, n equals 0 to infinity of 2n factorial 2 to the 2n and factorial squared times x to the 2n over 2n plus 1 dx. So here I can take this summation notation out here and just work on this series and see. It's a little bit of work here, but hopefully we'll go through this. Now, if I want to do this integral, I'm going to use the reverse power rule, which is going to be 2n factorial. In here, we're going to add an exponent and divide by that exponent. 2 to the 2n and factorial squared times x to 2n plus 1 over 2n plus 1 2n plus 1 squared from 0 to 1. And this series is now going to become, if you do the boundaries, it's going to become 2n factorial. 1 to the power of 2n plus 1 is 1. And 0 to the power of 2n plus 1 is equal to 0. So the second term that we're subtracting is going to go away. And we're only left with 2n factorial over 2 to the 2n and factorial squared divided by 2n plus 1 squared. So it is not so hard to see that these series do indeed converge, and it has a neat result of pi over 2 ln 2, which is approximately, if you type it in on a calculator, it's approximately 1.08879. And then so it goes on. So the exact results of the integral from 0 to 1 of arc sine x over x dx is pi over 2 ln 2. You might notice that it's incredibly similar to the integral 0 to pi over 2 x cotangent x dx, which is also pi over 2. I did this integral in my other video, and we can conclude that the integral from 0 to pi over 2x cotangent x dx is indeed equal to integral from 0 to 1 of arc sine x over x dx. And these two integrals are indeed equal to each other. Thank you for watching my video. Please like and subscribe, and I will see you next video.